Hello, welcome to the DL Software Digital Guide, a one-stop practical guide for DL software toolkits. This is part of the DLView video series that show you how to make best use of DLView effectively. In this video, I'm going to show you how to set up DLView and run the program. DLView is a powerful and robust software that enables users to set up a variety of force field models for molecular simulation calculations using DL Poly. To obtain a copy of DLView, you would first need to register yourself by visiting the website ccp5.ac.uk/dl_view. Follow the instruction in the website and you'll be sent a copy of the software via email. Please do register the software by using your institution email whenever possible, as other types of email may have a slight possibility of end up in a junk folder. Once you have obtained the software, download and save it in a folder in your computer. Now go to the folder and extract the files by using the tar command as follows. Your computer will create a new folder called DLF 4.8 which contains all the DLView files. The number 4.8 is to indicate the software version that you are using. Now let's go into the DLView folder. You'll notice there are a number of files and directories contained in this folder, of which we are not going into details in this video. You would now need to compile the codes before you can run DLView. To do this, go into the source folder. This is where all DLView source files are located. Provided your operating system is pre-installed with a standard C compiler, you are now in a position to compile DLView by simply issuing the command make, M-A-K-E, make. Once the codes are compiled successfully, let's go back to the main directory. You'll notice a DLView executable file appears. Note that the main directory where the DLView executable file is located would be your DLView home directory. Your configuration file, control file, or any data file will be read with reference from this home directory. Before running DLView, you would need to make sure DLView will be reading the correct data and control files. This information is kept in the DLF path file, which must also locate in the DLView home directory. In other words, if you move your DLView executable file away to a new location, you must also move the DLF path file to the same location. Let's see what is inside the DLF path files. It contains information that tells DLView the directory paths to which the needed data files are located. For example, the location for the force field library data files, the location for the solvent templates, and the output location for the DL Poly force field model files, which are the config and the field files. Most of the time, you would normally leave this information unchanged. What you would normally change would be the location or the file name of the DLView control file. The DLView control file is the only master control file that instructs DLView how you would want to set up your force field models. By default, it is pointed to the DL_field.control file, which is located at the DLView home directory. Once DLView is run, this would be the control file that DLView is going to read. You can obviously copy and rename the control files and put them in different locations. However, only one file can be specified at any one time. Let's look at the contents in the control file. A DLView control file always consists of a complete set of possible options that you can select. Each option is followed by a brief description and the available choices. Obviously, most of the options can be left unchanged. What you would normally change in the control file would be the force field schemes of your choice and your input configuration file. In this case, the CHARM22 force field for protein molecules has been pre-selected. A PDB protein file called the SOD1 located in the examples directory folder has also been pre-selected. For your interest, SOD1 is the superoxide dismutase protein enzyme that protects cells from oxygen damage. In human and in most other animals, the enzyme exists as a dimer. Now, let's run the DLView program. You'll notice messages will be displayed on the screen, highlighting the conversion progress of the protein structure into a suitable force field model for DL-poly program. If you see these messages, it means that the conversion process has been carried out successfully. Now, I'm going to show you how to set up a solution model. The system consists of two components. Once again, edit the DL. Before finishing this video session, I'm going to briefly discuss about choosing a suitable cutoff value for the solution maker feature. Now, let's run DLView and see what happens. This is the resulting DL-poly config structure set up by DLView. As you can see, the molecules are rather evenly distributed. In this example, we are going to use the original TIP3P water model. The value 1.9 was set to ensure the minimum distance between a solute and a solvent molecules must always be at. Now let's run DLView again and see what happens. Choosing a suitable cutoff value is as a matter of choice and trial and error, and also depends on the number of molecules and the size of the system.